Okay, so let's look at this information. A company produces steel rods. The lengths of the steel rods are normally distributed with a mean of 108.6. So that's our mu, or our population mean, and a standard deviation of zero point 0.5. So that's our um, population standard deviation, or sigma. And we have 50 steel rods bundled together. So that is our sample size N. Now, I noticed that you got C. C is a single steel rod, so we're going to use a different z-score calculation than we use for D, where we have a bundle or a sample of 50 rods. All right, so for C, I've written it on another sheet here. For C, we're going to use that Z is our whatever. I guess they had 108.5 and 108.6. We were looking for the same thing, but we do the 108.5 minus our mean of 108.6 over the standard deviation of zero point 0.5. And then we do exactly the same thing for 108.6. But for D, because we have a sample, we have 50 rods, we have got to use this formula right here that I've got written first. All right, so we're going to do it first for the 108.5. All right, so I'm going to do Z equals 108.5 minus the mean of 108.6 over the standard deviation of zero point 0.5 over the square root of our sample size of 50. And we need to quite different. And that ends up being negative 1.4142. All right, now we're going to look that up using Excel, and that will give us the probability that um, we are to the left or less than negative 1.4142. For between, we have to do both of our calculations, look up their probabilities, and subtract the larger probability minus the smaller probability. So we're looking this one up, negative 1.4142 in Excel. So I'm going to use equal norm dot, in this case, I use s.inv, and, oh, no, sorry, norm.dist, and we changed this to the standard normal distribution. So actually, let's use norm.s.dist, and I'm going to put in the negative 1.4142, 652. So let's see if I can write that down without losing it. Well, I'll just leave it there for the moment. All right, now we need to do a second calculation. We'll come back to that. Whoop. Um, we'll come back to this. The second calculation is really easy because, as we will see, all right, the second number we had was 108.6, which is exactly the same as our mean. So if we do this same calculation, but we put 108.6 here, minus the mean, the population mean was 108.6. And then the bottom of the fraction is still 0.5 over the square root of 50. All right, well, let's notice the top is going to be 0. So it really doesn't matter. We don't have to go through the calculation of the bottom is still what we got right here, 0.070710678. But since the top is 0, 0 divided by any number is going to be 0. So this z-score is 0. And let's remember that on our standard normal curve, 0 is right smack in the middle. So there is 0.5 to the left and 0.5 to the right. But if we forget that, we can look up that z-score and we'll see that it's going to give us 0.5. So equal norm dot s dot dist. If I put 0 in and true, let's notice that it gives me 0.5. All right, now I want to subtract these two values to get my final probability. And to subtract, I have to use an equal 0.5